So on homework 12, we're starting out with the domain of something that has both a fraction and a radical in it. And so we have to watch the domain for both sections. And so here, for my square root, the 7 plus x has to be greater than or equal to 0. If I move my 7 over, x has to be greater than or equal to negative 7. For my fraction, the bottom of my fraction, the negative 2 plus 2x cannot equal 0. So 2x cannot equal a positive 2, so x cannot equal 1 when I divide. Since this is included here, let's do this. Negative 7, everything going this way. However, at 1, I'm going to have a hole because I can't be equal to 1. I'm going to write my intervals as two separate intervals with a union in there. The first section goes from negative 7 to 1. I am including the negative 7, but I'm not including the 1. My second interval is starting at the 1 but not including it and going to the end of my graph, which is infinity. So my interval for my domain is going to look like that. So including the negative 7, going to the 1 but not including that, and then going from 1 to infinity and not including either ends of that. So on number 2, the entire fraction is under the square root. Normally we'd say the square root has to be greater than or equal to 0, but in this case our variable's just on the bottom, and so when we do this we would say 10 plus x. Normally we would say greater than or equal to 0, but since that's in the denominator, just has to be greater than 0. Because the denominator, 10 plus x, cannot equal 0, so we know x can't equal that negative 10. So we're just going to use the greater than instead of the greater than or equal to, because the bottom of my fraction can't be equal to 0. And so I'm going to move my 10 to the other side. X is going to be greater than negative 10. I don't know why I got the calculator up there, but it came up there. And so in interval notation, I'm not including the negative 10. I can use anything greater than that, so from negative 10 to infinity would be my answer. Now here on this one, we've got that square root underneath the fraction. First of all, because of the square root, x has to be greater than or equal to 0, right? We can't have that 0 underneath our square root. We also know that 2 minus the square root of x cannot equal 0. So if I move that over, 2 cannot equal the square root of x. I move that over so it'd be positive instead of negative. I'd have to square both sides. So 2 squared is 4. 4 cannot equal x. So x has to be greater than or equal to 0. Again, if I do my number line, however, at 4, I can't have the 4 under there because then I would have a 0 on the bottom of my fraction. And so my interval is going to go from 0 to 4, and then 4 to infinity. So I have to watch for both things, both the square root and the fraction, and see where I have values that are going to be undefined. 4, 5, and 6, we're doing the domain or the range of the graph of a continuous function. Remember that domain are our x values and range are our y values. So for our domain, we're using the x-axis, and we always go from smallest to largest, so we're going to go from left to right. Our range is our y-axis. Again, if I'm going from smallest to largest, I'm going to go from the bottom to the top. So if I'm going to list what my domain of this graph is, there's nothing back here. Our first point to the left has an x value of negative 3. My graph is continuous. The farthest point to the right has an x value of 5. And then, of course, I need my endpoints. The 3 we are including, we are on the graph. The 5 we're not including, so that's going to have a parenthesis. For my range, I'm looking at the bottommost point right here, which is at y equals -5. And my graph is continuous, and my highest point has a y value of 4. The -5 we are touching is going to have a bracket. The 4 has the open circle, is going to have a parenthesis. So when you're thinking about domain and range, domain you want to go from the farthest left point to the farthest right point on your x-axis. Range you want to go from the bottom point to the top point. So number 5, if I'm looking at that graph and I'm going to do my domain, my farthest to the left point has an x value of -2. My graph is continuous, and the farthest to the right point has an x value of 5. I'm not including the -2, I am including the 5. For my range, my bottom point on my graph has a y value of -4. The top point of my graph has a y value of 2. I am including the -4. I am not including the 2. And so there would be my domain and my range. The third one's a little bit trickier. Again, if I think about my domain is the farthest left point. The x value of that is at -3. To the farthest right point, the x value of that is a +3. I am including the -3. I am not including the +3. So that part wasn't so bad. But now when I think about my range, we said our range is the bottommost point on our graph, which is down here at -4, to the top point of our graph, which is up here at +5. This point right here doesn't have an open circle on it. It is a point on the graph. We are touching at -4. Up here, if I drew a line here, I am touching the graph at 5, so that is also going to have a bracket. If these were both open, then it would have a parenthesis, but since one of them's filled in, I am touching at that point, so it is going to have a bracket on it. All right, the next ones we're choosing the graph to fit the narrative. So it says a plane speeds up before takeoff. So if I'm going to speed up, here it's showing my plane speed is increasing. So that'd be the one that's showing me that the plane speeds up. Nicole stays in New York instead of flying to Texas. Well, her distance to Texas is not going to change if she just stays in New York. So her distance isn't decreasing to Texas or increasing to Texas. It's just going to stay the same. And so it's going to look something like that. On the next one, it says, the water in the lake evaporates due to heat. So when the water's evaporating, the amount of water is decreasing in the lake. So here, this graph here is showing that the amount of water in the lake is decreasing over time. It's evaporating. Kara walks from home to school. Her distance from home, as she walks from home to school, she's getting farther and farther and farther and farther from home. So her distance is increasing as she goes. And so it looks something sort of like that. Austin rides his bike at a constant speed. So if I'm going at a constant speed, my line should be straight across. A helicopter takes off straight up from the ground. We're thinking about the altitude of our helicopter. As it takes off, it's going up and up and up and getting higher and higher and higher. So you might think, oh, if it's taking off straight up, it's going like that. But here, the time isn't changing. As the time increases, the helicopter is going up and up and up and up. So that would be the best choice for my graph on that. So 10, 11, and 12, again, we're fitting the graph. It says Amanda is driving to work. She drives at a constant speed. She then stops to pick up breakfast after she continues driving to work at a constant speed. This is her distance to work. If she's driving to work, her distance is going to decrease to work as she drives. She's then going to stop, so her distance is going to stay the same. She's going to start again driving to work, so her distance is going to decrease. So looking at the graph, this is the best one. My distance to work is decreasing. I stopped, so it stayed the same. Then I speeded up and continued on to work slightly faster. And so that one would be my best option for my distance to work. Part B, Kira is driving at a constant speed. She then slows down to pass an accident. After passing it, she goes back to her original speed and continues driving at that speed. So this is showing the speed. She's driving at a constant speed. She then slows down, and then she goes back to her original speed and continues driving at that constant speed. So, she's driving at a constant speed, she slows down, then she speeds back up, continues driving at her constant speed. So that would be my best choice. The next one. Anne is working out by riding her bike. She starts by biking slowly at a constant rate. She then gradually picks up speed until she reaches her peak. She maintains this peak speed for the rest of the workout. So, we're thinking about the speed. She starts out by biking slowly at a constant rate, so we want to be constant. Then she's going to pick up speed until she reaches her peak, and then she's going to maintain her speed for the rest of the workout. So she went constant, she picked up, went constant again. That looks like my best choice. Part B, a sightseeing ship is stopping in the water for an hour, miles from shore. The captain heads the ship back to shore at a constant rate. The ship docks at the shore for a while, then returns to the open sea. So we're talking about the distance from the shore. They're heading back, or stopped in the water for an hour. So, staying the same distance if I'm stopped. Then I'm going to head my ship back to shore, so I'm going to go all the way. My distance to shore is going to be 0 because I'm at the shore. I'm going to dock for a while, and then I'm going to start heading back out to sea. So, out of my choices, that one looks like my best choice. Number 12. Number 12 says, Tommy steps out of the pool and climbs the ladder to the high dive. He waits there, getting scared. He eventually climbs back down, but then gets enough nerve to start climbing the ladder again. So this is a distance above the pool. If he's on the ground, he's at 0. So he's going to climb up the ladder. He's going to wait there. But then he climbs back down. So climbed up the ladder, waits there, climbs back down, then starts climbing the ladder again. So That second one there looks like it's the best choice. The population of the large city remains constant for several years. The population grows very quickly for a few years until the city becomes quite crowded. After this, the population still grows, but it grows more slowly than before. So, population remains constant. Going to be one of these two because it says it's constant. The population grows very quickly. So my population is growing. After this, the population still grows, but grows more slowly. Here the population stays constant. So this one is the one we probably want. It's constant, grows quickly, still is growing, but not quite as much. So that would be my best choice on that one. So picking out which graph looks like the best one based on if it's increasing, decreasing, constant, what is my story telling me? Changing gears here, we're going to graph an absolute value equation. And since we're graphing an equation, this one is not going to have a center at 0, 0. If it was just the absolute value of plane x, then my center's at 0. But this is going to have a shift to it. So if x plus 4 equals 0, then x equals negative 4 is where the middle of my graph is going to be. When I graph an absolute value function, it's sort of going to look like a V. So what they're going to do is they're going to make their table, and they're going to use negative 4 in the middle. Now, technically, you only have to have 1 point on each side, so they're just going to check negative 3 and negative 5 in order to draw their graph. You could do more points just to make sure your line's going straight, but they're just going to use those 3. So what they're going to do is plug those points in and solve. I'm going to start by solving the one with the negative 4, which is my vertex. If I do negative 4 plus 4 is 0, 2 times 0 is 0, so then I get that minus 3. So negative 4, negative 3 is going to be the vertex of my graph. Then I'm going to do my other points. If I do negative 3 in there, negative 3 plus 4 is 1. 2 times 1 is 2. 2 minus 3 is negative 1. So negative 3 is at negative 1. Then they're going to do the negative 5. Now when they do the negative 5 plus 4 is negative 1, but it's in the absolute value. So that negative 1 changes to a positive 1. 1 times 2 is 2, and 2 minus 3 is negative 1. You'll notice you get the same value for both the negative 3 and the negative 5, or at least you should, because the absolute value turns your negative into a positive after you've simplified. Now what they're going to do is they're going to use the graphing tool, and they're going to take the ruler, click on the vertex in one of the points, and draw up through that point. Then click on the vertex and the other point and draw up through that point so that you have your absolute value. I have noticed it doesn't like it if you stop on the end point. You need to keep going through there. And like I said, you could do 2 more points just to make sure everything's lining up nice and straight. On Alex, they're just going to put the 3 points on there, and you get the idea of what your graph looks like. So on number 14, same kind of thing. I'm doing an absolute value function. I know it's going to look like a V. X minus 1 is going to be my shift. And so when I move that over, x equals 1 is going to give me the x value of my vertex. And so in my table, 1 is going to be in the middle. And so I'm going to use 0 and 2 as the other 2 points on the sides of 1. So if I put 1 in there, 1 minus 1 is 0. The absolute value of 0 is still 0. 0 times negative 2 is still 0. I get the minus 3 that's on the end. So 1, negative 3 is where my vertex is. If I put 0 in there, 0 minus 1 is negative 1. However, the absolute value of negative 1 changes it to a positive 1. 1 times negative 2 is negative 2, and negative 2 minus 3 is negative 5. When I do the 2, I should get the same answer. 2 minus 1 is 1. The absolute value of 1 stays 1. 1 times negative 2 is negative 2, and negative 2 minus 3 negative 5. So 0, negative 5, and 2, negative 5. So this time my absolute value graph goes upside down. Since that coefficient was negative, it reflected it across the x-axis, and so it's an upside down V. Number 15 then, if I look at this, the x value of my vertex is going to be at negative 3, because negative 3 plus 3 is 0. The y value of my vertex is going to be that 4. So negative 3, 4. If you want, put it in there, solve it, you'll see that you get that. So my x value is the opposite here. My y value, whatever that end number is, because that gave me 0 plus 4 is 4. So 2 points, I want to use negative 2 and negative 4 then to be the 2 points right next to that. Negative 2 plus 3 is 1. The absolute value of 1 is 1. 1 times 3 is 3, and 3 plus 4 gives me 7. Negative 4 plus 3 is negative 1, but the absolute value of negative 1 is positive 1. So 1 times 3 is 3, and 3 plus 4 also is 7. So negative 2 is up to 7. Negative 4 is also up to 7. I can then draw my absolute value graph. Again, that was a positive 3, so my V goes upwards when I draw. (16, 17, 18), we're graphing a parabola in the form of a minus x squared plus c, again where we can see the shift to our graph. Now on the parabola, they are going to make you do 5 points instead of just 3 points. But again, on my vertex, my shift on the x is going to be at negative 4, because if x plus 4 equals 0, negative 4 plus 4 is 0. So x is going to be negative 4. My y value then is going to be positive 1. 0 plus 1 is 1. So I'm going to be at negative 4, positive 1 for my vertex. They're going to make you do 2 points on each side, so negative 3, negative 2, negative 5, and negative 6, and plug those numbers in and solve. So if I put the negative 2 in there, negative 2 plus 4 is a positive 2, 2 squared is 4, 4 plus 1 is 5. If I put my negative 3 in there, negative 3 plus 4 is 1, 1 squared is 1, 1 plus 1 is 2. When I put my negative 5 in there, negative 5 plus 4 is negative 1, but a negative 1 squared makes it positive 1. 1 plus 1, 2. Negative 6 plus 4 is negative 2. A negative 2 squared is a positive 4. 4 plus 1 is 5. So since this is going to be a parabola, these values match up, these values match up, and of course our vertex is in the middle. So negative 2 is up to 5, negative 3 is up to 2, negative 5 is up to 2, and negative 6 is up to 5. You'll hit the graph button and have your parabola, if I could hit all my dots. Looks like a U. Again, my coefficient is positive, and so my U goes upwards. And looks something sort of like that. And so number 17, if I'm going to graph my parabola, my vertex of my parabola, the x value has to be a positive 2 to get 0, and 0 plus 4 is going to give me 4. So 2, 4 is going to be where the vertex of my parabola is. This will give me the horizontal shift, this gives me the vertical shift. So over 2, up 4 is where my vertex moved to. And then I want 2 points on each side of that. 2, 1, 0, and 3, and 4 would be my 2 points on each side of 2. I put 0 in there. 0 minus 2 is a negative 2. Negative 2 squared is 4. 4 plus 4 is 8. 1 minus 2 is negative 1, but a negative 1 squared makes it a positive 1. 1 plus 4, 5. 3 minus 2 is 1. 1 squared is 1. 1 plus 4, 5. 4 minus 2 is 2. 2 squared is 4, and 4 plus 4 is 8. Again, those numbers should match up like they do. So 0 is up at 8, 1 is up at 5, 3 is also at 5, and 4 is up to 8, and I have my parabola when I hit my graph button. Number 18. Here, my x value in my vertex is going to be at -3. My y value will be the -2. So my shift, I went back 3 and down 2 for my vertex. So 2 points on each side of that, -2, -1, -4, and -5. So -1 plus 3 is 2. 2 squared is 4. 4 minus 2 is 2. -2 plus 3 is 1. 1 squared is 1. 1 minus 2 is a -1. -4 plus 3 is -1, but a -1 squared makes it +1, and 1 minus 2 is a -1. -5 plus 3 would be -2. -2 squared is a +4. 4 minus 2 is 2. So -1 is up to 2. -2 is at -1. -4 is at -1. And -5 is up to 2. And again, I've got my graph of my parabola. (19, 20, and 21 are graphing a square root function. And keep in mind that the part underneath the square root has to be greater than or equal to 0. So you're going to have a whole side of your graph where you don't have anything drawn on it. What you want to do is you want to take the part under the square root and set them equal to the first 4 perfect squares, because it's going to want the end point and then 3 points after that. So I'm going to take the x plus 2, which is the part under the square root, and set it equal to 0, which is your smallest perfect square. And then 1. 1 squared is 1. 2 squared is 4. And 3 squared is 9. That's going to help you find what values you want to use to substitute into your table so that you can find points that come out nice on your graph. So here, I'm going to minus my 2. Here I'm going to minus my 2. Here I'm going to minus my 2. And here I'm going to minus my 2. So in my table, I'm going to use -2, -1, a +2, and a +7. That's going to give me values that come out nice so I can plot my points and do my graph. So, -2 plus 2 is 0. The square root of 0 is 0. And 0 times the -2 in front still is 0. So, -2, 0 is going to be the end point of my graph. Then I'm going to put in the -1. -1 plus 2 is 1. The square root of 1 is still 1. 1 times the -2 in front is -2. So -1, -2. I'm going to put in the 2. 2 plus 2 is 4. The square root of 4 is 2. 2 times the -2 would be -4. So 2 is going to go down to -4. Then I'm going to do one more. 7 plus 2 is 9. The square root of 9 is 3. 3 times -2 is -6. So 7 is going to be at -6. 1, 2, 3, 4, 5, 6. When you hit the graph button then, it's going to start here, curve down, and it's going to shoot off that way for the rest of my graph. And so that's what my square root function is going to look like. It's going to have an end point and only go in one direction because all the square roots of the negatives are undefined. So number 20, same kind of thing. I want to take the part that's under the square root, which is the 1 minus x, set it equal to my first 4 perfect squares. So 0, 1, 2 squared is 4, and 3 squared is 9. I'm always going to use 0, 1, 4, and 9 because those are my first 4 perfect squares. I'm going to solve these, and so I'm going to solve this one. I'm just going to minus my 1 and divide by -1. So a negative divided by a negative makes it a positive 1. So here, I'm going to minus my 1, which is 0, and 0 divided by -1 is still 0. Here I'm going to minus my 1, which is 3, but divide, so -3. Here I'm going to minus my 1, which is 8, divided by -1, so -8. So in my table, the x values I'm going to use, 1, 0, -3, and -8. So 1 minus 1 is 0, square root of 0 is 0, and 0 times 3, still 0. So 1, 0. Putting a 0 in there. 1 minus 0 is 1, square root of 1 is 1, 1 times 3 is 3. So 0, 3 is on my graph. 1 minus a -3. When I minus a negative, I'm going to add the 3, so I'm going to get 4. Square root of 4 is 2. 2 times 3 is 6. So -3 is up to 6. And then -8. Again, 1 minus a -8 means I'm going to do 1 plus 8, which is 9. Square root of 9 is 3, and 3 times 3 is 9. So -8 is up to 9. And so my graph is going to start here, and it's actually going to curve and go this way. Looks something sort of like that. And 21, the whole entire thing is underneath the square root. So -2x minus 3 we want to equal 0. -2x minus 3 we want to equal 1. -2x minus 3 we want to equal 4. And -2x minus 3 we want to equal 9. And then we're going to solve those so we can find the x values in our table. So here we're going to add our 3. And so x is going to equal -3 halves, 3 over -2. Here I have to add my 3, which is 4. 4 over -2 would be -2. Here I'm going to add my 3, which is 7. So I'm going to get 7 over -2, or -7 halves. And here I'm going to add my 3, which is 12. 12 over -2 is -6. So -3 halves, -2, -7 halves, and -6. So putting my -3 halves in there. -2 times -3 halves minus 3. So the 2's are going to cancel. Negative and a negative is a positive. 3 minus 3 is 0. The square root of 0, 0. Then I'm going to do my -2. That's a nice whole number. So -2 times -2 is 4. 4 minus 3 is 1. The square root of 1 is 1. Then I'm going to do my -2 times my -7 halves. The 2's again will cancel. A negative and a negative is a positive. So I get 7 minus 3, which is 4. The square root of 4 is 2. Then -2 times -6 is a positive 12. 12 minus 3 is 9. The square root of 9 is 3. So on this one, I'm going to have to use that plot point tool because I've got those fractions. So I'm going to have to type my ordered pairs in. I'm going to just estimate it. -1.5 is at 0. -2 is at positive 1. -3.5 is up at 2. And -6 is at 3. So this graph is going to look something sort of like that. So whole key to graphing my square root functions is to take the part underneath the square root. If it's on the outside, we don't have to worry about it. But the part under the square root, set it to our first 4 perfect squares so that we end up with nice answers that we can enter in on Alex.